Okay, we have a new table. We have actuary life tables. This is data from 2022. It was published in 2025 from the Social Security website. It tells us for given age for both males and females, the percentage of life expectancy. In the website, it gives you every single age, but just for the purpose of practicing linear interpolation, I'm giving you the percentages at every decade. So remember, we're going to use slope as a way of this linear interpolation. And the idea is we're basically drawing a linear line between two known points given here and try to find a point in between those 2 points using that same line equation. So that's why we're using slope. Now, remember, we can use either age or life expectancy as our x or y. It really doesn't matter. For this example, I am using age as my x component and y as the percentage of life expectancy. All right, so let's take a look at some of these questions. If you feel comfortable with linear interpolation and you want to try it on your own, go ahead. Two separate columns, right? Male or female, and the question is just specifically to use those specific ones. All right, so males at 20 years old, you would use 20 and 30 years, the data from 20 and 30 years, and the column for males. These are all in percentages. And the first thing you would write out is this ratio of slopes, or equate this ratio of slopes. So we have 30 and 20 years. So at 20 years, we have 55.63%. And at 30 years, we have 46.51%. Now, remember, the main thing for linear interpolation is that you set it up and you're consistent. It doesn't really matter if for each side the slope is either positive or negative, or if you flip the ratios, as long as you're consistent on both sides, you're fine, right? And what we're solving for is the percentage of life expectancy for males at 20 years old. So that's the y term that we're trying to solve for. So we change from 30 years to 28 years down here to match the y3, x3 terms that you see in this slope relationship. So if I isolate this, what we're trying to solve for, we get 48.334%. And remember, the key thing that you can always check for is this value has got to be in between these two values. If it's not, then something is wrong in the setup or as you punch it into your calculator, right? So try the same thing for problems 2 and 3. At 92 years, we're going to use 90 and 100, right? Because this is interpolation, so you're bracketing what you're looking for. Now, realistically, could you use 150 and use those? Yes. But the closer your data set that you use, the more accurate and the closer you are. You can always take this data, go to the website, see how close we are actually matching, right? Because there is data for every single year on the Social Security website. So we're going to use 90 and 100, and since this asks for females, we're going to use this column, 4.62% and 2.14%. So we'll set up in the same way. And now we're solving here. And when we rewrite it, we get 4.124%. And again, you check and you are in between these two given values. And finally, 42 years old, very similar pattern. We're going to use 40 and 50 years. So we're going to have 41.86% and 32.73%. We're solving for this term right there. And we see we get 40.034%. All right, so hopefully you see a pattern. You can rewrite the equation so you go directly into the final form. But in my opinion, I always go to the balance of the slopes because I don't need to memorize anything. I just need to remember rise over run in the two different sets, right? We have 3 points. So for example, in this this third example for 42-year-old females, I have 1 point of 40 and 41.86%. I have a second point of 50 years and 32.73%. And my third point is what I'm trying to solve for, 42 years, and what we solved for was 40.034%. So you have these 3 points, one of which you have a component that you're solving for. That's all linear interpolation is looking at.